Good, recorded. Okay, let me share the slides now. All right, can you see the slides now on the screen? Okay, brilliant. So I'll make it full screen. Okay. Okay. So any of you ada connection problem, just in case? You can, kalau you are disconnected, just rejoin, that's fine. It's part and parcel of this online class. So, all right, welcome to ZAT386, Physics of Semiconductor Devices, right? This is a course introduction. So I'm Zamir Pakhuruddin. My room is at 205, School of Physics, so level 2. So the part lab, like medical, right? Medical biophysics. So you're going to learn about the physics of semiconductor. So when we talk about semiconductor, what crosses your mind? What crosses your mind when we talk about semiconductor? You can unmute yourself, you can put in the chat box, that's fine, as long as we interact. What crosses your mind when I talk about semiconductor? Doping? Yep, okay, that's good, doping. Okay, anything else? What else? Any keywords that cross your mind when we talk about semiconductor? Anything? Have you seen semiconductors? Transistors? Good. Are we using any semiconductors now? Energy band? Yep, perfect. Silicon? Good. What else? Silicon, energy band, transistor, doping. Ada lagi? Solar panel, yep, solar panel, that's my area. Oh, Amirul, patutlah. Amirul saya punya FIP. And you're working on solar cell as well. All right, what else? Silicon wafers, yep, silicon wafers. So you can see at least something in the picture, right? The chip in this picture, wafers, sand, okay? So these are among the things that we're going to learn in this course, physics of semiconductor. When you talk about semiconductor, in this course, we're going to learn about two parts. So you can look at the name of the course, physics of semiconductor devices. So we're going to learn about the physics of the semiconductor, and then we're going to see how do we apply all the physics or some of the important physics to the semiconductor devices. Okay, so as I said, there are mainly two parts. So we're going to learn about the physics of the semiconductor, and then like what doping, energy band, Fermi level, band gap, valence band, conduction band, in which some of those have been learned in the previous courses, partly in solid state physics 307, for example, right? Ada lagi yang joining ini. Let me just admit some of your friends. Okay, and then in the second part, since we have 14 weeks altogether, so we're going to learn the physics in the first part, in the first half of the SEM. So that's about 7 weeks. And then in the next 7 weeks after the SEM break, we're going to learn about the devices. And when you talk about semiconductor devices, we have range of semiconductor devices that we are going to learn. So at least some you can see here. So you can see in the first picture, that guy holding, what is that? What is that in the picture? Silicon wafer, right? Silicon wafer made from silicon, made from sand, which is silicon dioxide, remove oxygen in order for us to get the silicon, and then we have to purify the silicon through a number of processes to end up with certain purity of silicon that we can use to fabricate semiconductor devices. And the devices can be transistors, can be MEMS, can be solar cells, can be LEDs, lasers, and stuff. Okay, some of the applications are can be seen here in this picture. So let me go through the learning outcomes of this course. So at the end of this course, you are expected to be able to, the first one is explain theories, the characteristics, and operation of characteristic of materials and operation of semiconductor devices. So that's the first course outcome, which is related to P01 or program outcome number 1, which is more related to knowledge. So the second one is you are expected to solve problems involved in semiconductor devices, not only at device level, but also at material level. And this is more related to PO3 or program outcome that's related to thinking and scientific skills, calculation, analytical skills, and whatnot. The third one is you should be able to present operation of semiconductor devices clearly and with confidence. So we're going to have a presentation in this course towards the end of the course, perhaps sometime week 12, 13, I think. And of course, it's more related to your communication skills. Even though we can't do that physically, we don't know yet because it's too early to tell. So at least if the course has to be conducted fully online, so we're going to do your presentations online, okay? We're going to figure that out later on. So if the situation improves significantly, the pandemic, so if you're able to come back to the campus and we can conduct physical classes, then of course we can figure out how to do physical presentations, okay? And this is going to be in group. So one of the examples, A8 chip, we're going to learn on the physics of the transistors, because when you talk about chips, you're talking about transistors at this point of time. So in this course, we're going to learn about the operation and what it takes for the device to operate. So you can look at the YouTube video later on. So the link is attached there, is given there. So tak apalah, it may not be clear at this point yet in terms of what is this stuff, CD and overlay. And CD actually refers to critical dimension, or the dimension that we need to print on our chip in order to make sure that the devices operate well. And in order to do this, we need to understand the operation of the device. So in this case, it's the transistor. And then you're going to learn on how do we actually do that in terms of the processing, the processes, fabrication and stuff in the next course, ZAT387 next semester. So will be taught by myself as well. So in that course, you will apply the fundamentals that you learn in this course and see how do we actually fabricate the device to turn the fundamentals into the actual devices after certain processes. So this is one of the applications that we're going to learn later on. And when you talk about printing process, so macam kita print baju, kalau you print baju, you're going to have like something printed on the shirt, right? So, and the process is quite crude, process yang simple lah. So when you talk about fabricating chips in the phone that we use now in your phone, in my phone, my laptop, and your other gadgets, for example. So we're gonna need to do the very same process, but instead of printing by mechanical setup yang kita ada dekat kedai tu, kedai printing t-shirt, so we're gonna use light to do the printing, light. So we're gonna use photons to do the printing. So that's why the process is called photolithography. So the name is called lithography or photo, but the full name is called photolithography. So lithography is the printing of the patterns or whatever, and the photo comes from photons or light that we're going to use to do the printing process. So photolithography in full is printing the circuit or the devices by using light. So we're going to learn about the detail of the process in 487. And before we go to that, we're going to learn on the basic, the fundamental, the theories, the operation of the devices in this course. Okay. So for example, if you want to print this, if you want to prepare this Kirin 990 chips, okay, so the device needs to be printed with a critical dimension. If you look at critical dimension, it's actually referring to the width of the line. Yang you tengok dalam ni, kat sini yang saya tunjuk in cursor. Okay, it's the width of this line is actually 15 nanometer. 15 nano ni. So can anyone tell me what's the width of your hair? So berapa ketebalan rambut kita? Can anyone tell me in the chat box, or you might want to unmute yourself? 0.3 mm. Yeah, close. Any other guesses? 0.3 mm is what? If you convert that into micron, then that's 300 micron, right? 300 micron. So any other guesses? What's your hair thickness? Anyone else? Rafa ini cakap 0.3, or that's 300 micron. Let me see the list here. Kita ice breaking sila today. Ice breaking. 0.1, Sakina said 0.1 over 100 micron. Yep, that's closer. Siapa lagi ni? Farhan. Farhan, what do you think? So we have 300 micron, we have 100 micron. Sama dengan apa ini? 300 micron. Okay, one last one. Andy. Andy, what's your guess? What do you think is your hair thickness? Close? Sama juga. Okay. That's about 100 micron. Okay, that's about 100 micron, or well, some may have 80 micron, some 100. Kita punya hair thickness pun berbeza-beza, ada range. So somewhere about 80 to 100 micron usually. Okay, so this is like 50 nano. If you talk about this series, like 50 nano. So nano is like divided by another 1,000, right? Micron to nano is like divided by another 1,000. So you slice 1,000 to get 50 nano, more or less. Okay, so that's very small, and to be able to do to print that circuit down to about 50 nano, you need to use lithography process, and not only lithography process. You need to use a process called EUV lithography. We're going to learn this one in detail later on. Or extreme UV lithography, where the illumination source, the wavelength, is about 13.5 nanometer, right? To be able to print this range, 15 or sub 100 nanometer, so you need to have lithography of that capability, okay? Don't worry yet, okay? Okay, if you talk about a CD of 7, which is roughly half the 15s now, is currently fabricated by TSMC or Taiwan Semiconductor Manufacturing Corporation using EUV process with illumination wavelength of 13.5. I put it at 10 to 14. So this is the king of semiconductor fabrication in the world now. So it's called TSMC in Taiwan. Okay, they are number 1 on the list. So if you talk about this Kirin, so it has about 10.3 billion transistors in about 200 mm squared of area. So in that chip, if you go down to 200 mm squared, so you're going to find 10.3 billions of transistors. And this is the equipment that I'm talking about, EUV lithography. Okay, one of the pictures on the right is EUV lithography. Such a big equipment. Okay, if you want to compare, if you want to put this into the actual size, if you talk about bilik tutorial, say BT 146, so that's about 3/4, I think, 3/4 of that BT. Okay, kalau dalam physical classroom senang saya nak tunjuk tapi online ni, so I can just give you an example. So that's about 3/4 of the BT 146, for example. So one piece, and to be able to run a production, so you need to have at least 20, 30 of this in the factory. And this is only for one process out of the many more processes that we have in the fab or wafer foundry, okay? So this is some news on TSMC. So they plan to start 3 nanometer fab construction with 19.5 billion USD. So in this course, as I said, we're going to learn the physics in the first part, in the first 7 weeks, and then you're going to have your mid-sem break, and then you're going to come back, you're going to learn on the devices in the second half of the course. So some synopsis of the course, let us just go through pretty much what you have mentioned just now when we just started. So this week we're going to learn Introduction to Semiconductor Materials, where some contents will recap on what you've learned before. So a recap on the crystal structure, energy band, Fermi energy, and then next week we're going to go through density of states, or DOS, probability of occupation, and then how do we then calculate density of free electrons available or free holes available in our semiconductor material. Week 3, we're going to go through intrinsic carrier concentration. So what is intrinsic? We're going to cover extrinsic as well. So intrinsic is the opposite of extrinsic. Intrinsic is the pure material where you don't do any doping at all. And when we talk about extrinsic, we're talking about doping that material with either p-type or n-type dopant to be able to improve the conductivity, electrical conductivity of our semiconductor. And that process is called doping. And at some point, if you dope your semiconductor too much, our semiconductor will be turned into a degenerate semiconductor. Okay. So week 4, we're going to go through carrier transport phenomena, where we're going to see the movement of carriers, electrons and holes. How do they drift? How do they diffuse through the material? And then how do we actually generate new carriers? Okay, generation of and recombination of carriers. And then after we generate the new carriers, they will suffer they will go through recombination process naturally in a split second. So we learn how that takes place as well. And then in the next week, we're going to look at excess carriers in semiconductor and minority carrier lifetime, concept of diffusion length, which is derived from the minority carrier lifetime. And then we're going to go through continuity equation. Week 6 and 7, we're going to start looking into p-n junction. So week 6, we're going to go through p-n junction at thermal equilibrium condition, the moment you join your p-type semiconductor and n-type semiconductor together. So we're going to see what actually takes place when you join a p and an n material together, and you just leave it there until it reaches thermal equilibrium. And then what is going to happen then if you apply forward bias and reverse bias to the same junction. And then we're going to learn about diode equation, okay, based on our p-n junction. And also we're going to look into how our p-n junction is going to be affected under indoor illumination. Under illumination, not indoor, also outdoor. You can combine your p and n, and then you can put some light on top, for example, for application of solar cell, where it's actually a p-n junction, and they put it under certain spectrum of sunlight, whether it's outdoor, under the sun, or indoor, under LED, or incandescent, or whatnot. So we're going to see what exactly happens in our p-n junction. And then what causes our junction to break, or junction breakdown. And then you're going to go off for your mid-sem break. Okay, so those are the first part of the course. So these are basically all the fundamentals that you need to understand in order to comprehend the second part of the course. Okay, kalau you punya understanding in the first part is not so good, then it will affect your understanding in the second part, because second part is a little bit more complicated, because we're talking about devices with different operation and different device architecture and stuff, where you're gonna need to use some of these theories in the first half in combination kind of mode. Okay, you can pakai certain characteristics, certain theories, certain fundamentals at one time to be able to explain the device operation in the second part. So therefore, understanding in the second part is super crucial. Right, week 9, we're going to look at metal semiconductor junction. So when you put metal on semiconductor, apa akan jadi? So we're also going to look into semiconductor heterojunction. Say if you put Z oxide on silicon, so two different materials, two different band gaps, so what's going to happen? So what is the difference between these two homojunction, in which you join p-type silicon and n-type silicon together? same band gap but different polarity. So how the difference looks like. Okay. And then fundamental of MOSFET, metal oxide semiconductor field effect transistor, and then metal oxide semiconductor, MOSFET with additional concept. And then we're going to look into various devices as well, like BJT, JFET, photo detectors, LEDs, lasers, solar cell, power devices. Okay, so those are the second part of your course. So is it okay so far? Can you follow so far? Okay, clear? Good. All right. Let me just go through first, and kalau ada soalan you can discuss. So altogether 14 weeks, 7 plus 7, 7 before and 7 after. So lecture schedule ni yang saya nak bincang sebab you kata ada clash kan. So some of you highlighted to me in your emails and in your WhatsApp before, kata you ada clash. So we're gonna have our classes on every single day except Friday. So as of now, we're gonna conduct everything on WebEx. Belum ada physical classes until further notice. So let's go through every single day and see who have clashes and who have not, who do not have clashes. Okay, Monday, ramai ke ada clash?
Banyak
okay, oh, ramai. Okay, banyak So, can we do Monday other times, for example? Are you guys free on Monday? Let me see, morning, if I have. Is it okay Monday morning? Can we replace this? You're talking about 9, okay, 9 a.m., yeah? Okay, 9 a.m. morning can. Oh, 2 p.m. So, okay, any other suggestions? 9, 11, so morning can. Okay, what if, how about, oh, you're in class 9. How about Monday 10? Monday 10, anyone? You can turn on your mic or we will type as well. Monday 10, okay. Oh, I got class at 10, okay. 10
Doctor,
cannot.
I got class at 10.
Okay then, all right. Okay, so 10 cannot, 9 cannot, 11? 11 okay tak? 11 okay. Okay. Cannot, alamak, okay, cannot juga. How about Monday 12? Okay, Monday 12? Can. Cool. Yes, please. Still got pass. All right then. So lunchtime 2 to 3. Monday 2 to 3. Oh, tak boleh juga Clash juga. 3 to 4 of course cannot. 4 to 5. Selepas subuh. Okay, 4 to 5. How about 4 to 5? Clash juga. No. So Monday, no. Okay, hold on. Tuesday we have a class. Okay, Tuesday we have a class at 10, right? Can we do it 9 to 11 instead 10 to 11? Or 10 to 12? Tak boleh. We can make it 2 hours kalau okay, you have a class at 9. How about 10 to 11? Tuesday. Kita combine dengan kita punya current class, add another 1 hour at the back to make it 10 to 12. How about that? Can clash. Alright, tak boleh Then Tuesday cannot really, afternoon saya tak boleh, saya ada class, saya ada lab. Okay, Wednesday we have class 9 to 10. How about 9 to 11? 9 to 11 Wednesday. Looking good. Cannot. Yeah, we have a class 9 to 10, right? This class 9 to 10. So kita extend another one hour, 9 to 11 instead. Cannot? Okay, cannot then. Okay, Thursday we have class. Thursday we have a class 10 to 11. How about 10 to 12? Can 10 to 12. Thursday 10 to 12. Can. Please all can. Please all can. 10 to 12. Okay, yep, looking good. Cannot. You class yang kelas apa? NA? Cannot juga. Okay, more than one already. So, Thursday. Friday morning then. Friday morning 10. Is it okay? 10. Friday 10. Friday 10 to 11. Okay. Okay, please. The rest? Cannot. 11 to 12. Friday 11 to 12. Hazwani, can ke cannot tu? Oh, cannot. Cannot juga. Alamak, dah habis lah then. Then Thursday, Friday afternoon saya ada lab. Friday 9 to 10. Friday 9 to 10 then. Friday 9 to 10. Okay. Okay, good. Friday 9 to 10. Friday 9 to 10. Okay. Ada yang cannot ke? Friday 9 to 10. Can. Cannot juga. Then we are out of time already. So ada yang cannot tu. Akilah cannot. Any other proposal? Tuesday. Monday, Monday cannot. If not, then any other suggestions? Okay.
What about afternoon?
Afternoon, okay, what time? Which day, what time?
Friday or Tuesday?
Friday, I have Friday prayer. Tuesday, yes. Yes. Tuesday, yes.
Tuesday cannot. Maybe Thursday or Wednesday.
Afternoon, you mean 1 to 2? 1 to 2, okay. So can you do 1 to 2 any day then? If that's the case, we can do 1 to 2 Monday. Any day, okay. Then okay lah.
Monday should be okay also.
Okay then Monday. If that's the case, then we just swap our Monday 3 to 4 to 1 to 2. Problem solved. Okay, kan? Okay, I forgot about the afternoon. Good idea. Thank you very much. Okay, brilliant. Solve. Monday 1 to 2. So next Monday, I'll see you 1 to 2 then. Saya ada schedule dulu kat sini before I forget. 1 to 2. All events. Yup. Okay, done. So Monday 1 to 2. Saya dah book kat saya punya phone, is okay. So tak apa, nanti kat sini saya akan ubah. So Monday 1 to 2. Tuesday all good, right? No clashes, is it? Tak ada clash kan? Tuesday. Yeah, Monday 1 to 2 confirm. Now let's talk about Tuesday. All good, right? Tuesday? No clash. Brilliant. Okay. Cool. Great. Tuesday done. Tuesday is done. So Wednesday is okay, right? No clash. Tuesday 9 to 10. Clash juga. Okay. Alrighty. Hold on. Wednesday. Kalau tak ada option, kita 1 to 2 je lah, senang. Wednesday. Wednesday saya ada apa? Wednesday, today is what? Today is 22nd, right? 22nd. Okay, Tuesday. Oh no, Wednesday, right? Wednesday, sorry. Okay, Wednesday. You had a clash. Okay, right. Okay, Wednesday 11 to 12. Okay, how about 11 to 12 Wednesday? Okay, sure. Okay. You reply. Keep replying. Just in case if cannot, so Monday I put down here 1 to 2. Wednesday. So all good, right? Clash. Then So do you want a lunchtime class as well? I'm fine. 1 to 2? 10 to 11? Okay, 10 to 11. How about 10 to 11? Yeah, let me just go through your comment. Student who take LSP 402, 11 to 12. Okay, not okay. 11 to 12. Oh, 10 to 11 cannot. 9 to 10 cannot. 10 to 11 cannot. 11 to 12 cannot. 1 okay. 1 more okay kot. 12 to 1 tadi bukan ada class kah? Oh no. 11 to 12. So how about 11 to 12? No, 12 to 1, right? 12 to 1. 12 to 1, how about it? Cannot. 1 to 2 then. Okay, not kelas petang. Let me see, Wednesday, whatever. 1 to 2 lah, boleh. Okay. Wednesday 1 to 2 sama macam Monday. Alright then, solve. Okay, done. Thursday? Thursday okay kah? 10 to 11? Is everyone okay? 10 to 11? No clash. Okay, good. Okay, done. So to recap, kita ada 2 adjustment. So the first one is Monday. So we're gonna move to 1 to 2. Then Wednesday as well, 1 to 2. Okay, Monday and Wednesday, new schedule. Nanti saya akan update on the slide and I'll email to you the latest one on Elin. All right, done. Let's move on to the next one. Okay. So cost assessment. Cost assessment is going to be a 50-50 class. So that means you're going to be assessed on 50% of coursework and 50% of final exam at this point of time. Okay, at this point of time, no guarantee yet because we don't know what's going to happen next. But this is the default plan for, I believe, for every course. So it's 50-50. If the situation doesn't permit, then we might have to move to 100% coursework as well, just like we did what we did last semester and last 2 semesters, right? Due to COVID. So as of now, let's stick to 50-50. So you're going to be assessed on 50% coursework and 50% final. And for your coursework, you can look at this table up here. So you're going to have 2 tests. So 1 test before mid-sem break, 1 test after mid-sem break. So that's gonna be 7.5% each. So it's gonna make 15% altogether out of the 50%, and you're gonna have 1 assignment worth 15% in the first half of the course, and then you're gonna have a group presentation worth 20%. Okay, so 15 plus 15 plus 20, so that makes 50%. And in this case, you're gonna have another 50% from your final exam. So it's going to be, since it's 50%, so we're going to have 3 questions all together, and it's going to take 2 hours. We don't know yet how's the format and everything because we need to be sure of the condition first. But if we were to proceed with this, then it's going to be of this format, right? So answer all 300 marks, but let's see how do we move along the way. Okay. If we have to shift to 100% coursework, then you're not going to have any final exam component, but we're going to scale up the coursework component to 100%, where you're going to have your tests to, instead of 15%, it's going to be 40%, 40. So in that case, you're going to have 20% contribution from each test. So 20% from test 1, another 20% from test 2. So that's going to make 40% altogether. And the remaining 60% is going to be from assignment, 30%, and presentation, 30%. Okay. So we'll see because we haven't got any directive from the top management yet. But as of now, let's just assume that we're going to proceed with 50-50. So this is the reference book, the main one, not everything, but the main reference. I'm going to use Donald A. Neiman from this Semiconductor Physics and Devices book. Okay, you can refer to this book. I believe it's also online on PDF. Okay, so yeah, I also use some other reference books. You can look into SMZ and BG Streetman. Okay, but this is not entirely the whole content. It's not the whole content of the course. So don't only depend on lecture notes, do extra reading from various sources. And now since we are going online, so you're gonna have a lot of I call a lot of time and resources as well online. Okay, attendance, not everything will be in the notes, so do not miss your classes. I do explain new things as well by drawing and by online references in the class. Okay, late submission of assignment, late submission will not be marked and entertained, so try to be on time or before time. Okay, so plagiarism, I don't want to repeat this because you are in your third year already, so you know what does it take and what's the implication of plagiarism. Okay, need a class rep, class representative just in case, but now we already have a group, so it's a lot easier to communicate compared to last time. But anyway, just in case, anyone will be the representative. Maybe Faris got, Faris dah create group kan? Okay, with you Faris? Okay, go Faris. Okay, good, thank you. All right, the students are only allowed to sit for exam if, okay, this one is your attendance. It depends on your attendance. If you miss lots of classes, then you can be barred by procedures, okay? So please watch the class properly. So why is this course important? So I would like to tell you why is this course important. So what you see here is a door, right? So if you can summarize to me, whatever your program is, pure or applied or medical, what have you learned so far in the last 2 years from physics? Anyone would like to write down anything, or you like to talk? You can summarize to me in like 10 to 15 seconds. What did you learn from physics? Soalan cepu mas kalau you nak pergi internship nanti, you're gonna be asked something like this. So what did you learn from physics? How would you summarize in 15 seconds? Anyone? Any volunteers? Well, you can just summarize anything. There's nothing wrong to my question. Science dunia, yup, all right, science dunia. What else? Laws of math, good. Apa lagi? Just, it's okay, just put it down, it's all right. Manipulate nature, yeah, that's good. You learn about nature, you can explain about nature pretty much. What else did you learn from physics from the last 2.5 years or 3 years? Anything else? Nurul Nabila. Soalnya saya panggil nama based on the list just to get to know you more. Nabila, what did you learn from your previous years in physics? S345 dah kejapnya. Okay, what else? What else did you learn? Amirul. Amirul, how would you summarize to me in like 15 seconds? What did you learn from physics?
Saya belajar ialah math tu banyak. Lepas
Okay,
tu,
lots of math, okay. What else?
lepas tu tentang modern dan quantum physics. Yang tu benda yang baru lah bagi saya.
Okay, modern quantum physics, good. Okay, save the earth by properly utilizing resources. Yep, okay, that's good. So physics ni dia luas So I've seen a lot of answers: manipulate nature, properly utilize resources, math, science dunia, and so you learn many things actually. Okay. So you should be able to summarize what did you learn from physics in order to sell, inverted comma, sell your credentials, your background more. You're gonna see this to be crucial when you go for internship interview and stuff. And in fact, for your first job interview later on, you have to be able to connect your background to the world out there. So this course is one of the courses that's going to take you to cross. Okay. Saya nak buka pintu, nak tunjuk kat luar tu ada apa. Okay. Sekarang ni dekat dalam rumah kita ada physics. So you've learned lots of physics, maths, and you've learned a lot of techniques to utilize resources and stuff. So kat luar kita nak tengok ada apa. So this is one of the courses that will bring you there. Okay, so you're going to learn about important physics concept in semiconductor devices. So you've learned a lot already previously, math and fundamentals and solid state and a bit of material science perhaps. So now kita nak focus on important concept in semiconductor physics and semiconductor devices. So it's going to be a vital foundation to enter industry as a physicist, a scientist, an engineer in various kinds of industry, IC, LED, laser, solar PV. I'm going to show later on that we are actually blessed to be in the neighborhood. The Penang, the Pride, the Auto City, Kulim High Tech, we have a range of different companies from range of different industries that you can be in later on in the next 1-2 years. Important fundamentals if you want to pursue your studies in MSc, PhD, and you will eventually appreciate semiconductor devices more in your real life. Okay, I can guarantee you after this you can look at your iPhone or whatever Android a little bit differently at least, because you know what's going on inside your devices. So when you talk about these industries, ICs and lasers and optics and solar and LEDs and whatnot, they are actually clustered under EE industry in Malaysia. Okay, EE industry export represents the biggest export of Malaysia, at least if you see from this slide based on 2019. So it represents about 38% or 40% of our national export, okay, EE industry. So that means it's a very big industry in Malaysia. And if you talk about EE industry, all the eyes are going for Penang, okay, in Malaysia. Memang kita ada banyak lagi area kat Lembah Kelang and perhaps Johor and whatnot, but Penang, Kulim High Tech, Pride is one of the important areas in Malaysia if you talk about EE industry. If you talk about EE industry in Malaysia, so tadi EE industry is one industry. So now EE industry is divided into few subsectors, so few domains dalam EE industry. So the first one is called semiconductor, which represents what you're going to learn in this course and perhaps in the next course as well, fabrication, 487. Semiconductor is one domain, the other one is optoelectronic, LED. But the first one is like what Silterra is doing, Infineon and Intel and others. Optoelectronic is like Lumiled, Osram, solar is like First Solar, JA Solar, Jinko, and many more. System electronics manufacturers, we have a range of different equipment manufacturers in Malaysia that provide equipments to the industry in order for these industries up here to run, and also manufacturing related services. Okay, so and if you talk about this subject in particular, we are here for semiconductor. So you're going to learn on the basic, the fundamentals, the operation, how the devices look like in this course. And in the next course, if you take 487, you're going to learn on how do we actually prepare the devices before it goes to the market. So down here is EE value chain. So we have IC design. Kalau this is more towards EE punya graduate lah, yang create we call design the circuit. And then fabrication is more towards physics, material science, and walaupun other engineering discipline will join, but we're going to cover a lot on this. Okay, we're going to cover a lot. Assembly and test is more towards the back end, and dekat depan is more on the front end of the industry, where you actually fabricate the circuits and stuff. The back end or BE is more towards assembly and test the final products. Okay, and PCB is even back end as well. So you ambil semua all the chip and stuff, you pack on the board and then masuk ke hardware and motherboard and whatnot, and end up in consumer products and some other products. So we are here. So this course is very important. So in our neighborhood, we are blessed to have many giants. So we have Silterra in Kulim High Tech Park. So I was in Silterra last time. I was with Silterra for about 6 years. So we also have Infineon. Besides Silterra, we also have another Infineon doing backend in Malacca. We have Osram in Penang, Kulim High Tech doing solid state lighting. So you're going to learn about what you call LEDs and stuff. Vitrox doing inspection, right? Inspection machine. by optical, X-ray, and the rest. First Solar fabricating or manufacturing cadmium telluride solar cells. Jinko manufacturing silicon solar cell. Western Digital on the storage technologies, right? Storage technologies, and then you also have optic buzzers, which focuses on optics for optical system, optical components and stuff. So yeah, it's going to be learned a lot as well in this course. So companies with strong presence in Malaysia. So we have Japan, we have US, we have Singapore and German and whatnot. So you can see top brands here like Intel, WD, Keysight, Broadcom, Freescale, SunPower, yeah, many more. So this is what I call these are the main players related to semiconductor industry in Malaysia. So Malaysia, for information, is the world's third largest solar PV manufacturer in 2018 and onwards, behind China and Taiwan. So we have, if you talk about the solar manufacturing, we have all the top giants in Malaysia, like First Solar from US in Kuala High-Tech. We have Panasonic, even though it's they just announced that they are moving away from solar industry in Kuala High-Tech Park. We had their footprint here. We have Jinko in Prai. We have AO SunPower in Malacca. We have QCell in Cyberjaya. We have JA in Penang. So we have most of the top giants in Malaysia. So a bit of my background. Before joining academia, I spent about 7.5 years in Silterra and Fuji Electric in total. So I was an engineer by training. So I was in photolithography process last time for six years. Then I spent another 1.5 years doing R&D of sputtering process for hard disk drive industry. And the first one, Silterra, is doing semiconductor front end wafer fabrication. So my background was in electrical engineering from Sheffield, and I did my MSc in USM and finished my PhD in solar engineering in Australia. Okay, my research is in photovoltaic materials and devices, mainly on solar cells. But solar cells, if you look at it properly, it's one of the semiconductor devices that we use. So the operation, the fundamentals, the theories are all semiconductor based. So it's part of the course. So a little bit on my teaching philosophies before I finish. So in this class, I want you to understand this. So I believe there are no stupid questions from students. From Malaysia, I think, at least in our context, kadang-kadang I think student malu nak tanya soalan because takut kawan kata itu pun nak tanya, soalan simple pun nak tanya. I don't like that, right? I don't like that. Even though you think it's simple, but if you don't understand, just ask. It's okay. Kadang-kadang if you ask, then your question might not only enlighten you yourself, but also enlighten some other friends. Mungkin yang tak berani nak tanya, atau malu nak tanya, okay? Ataupun takut, for whatever reason. But in my class, there are no stupid questions. Just ask. Okay, we can always discuss. I will always revisit the theory that you don't understand. I'll try my best to make you understand. So I believe engagement with students enhances learning experience. So that's why I encourage answering in this chat box and unmute yourself, talk about it, give your opinion, and let's discuss. I believe understanding beats memorization. So understanding is more important than memorization. So you can watch 3 Idiots. Ada yang dah tengok 3 Idiots belum ni? Mungkin dah tengok kot Kalau you tengok 3 Idiots, then you can perhaps relate to my point here, understanding beats memorization. So in order to excel in life, you have to go beyond memorization. Memorization is very basic. If you talk about high order thinking skills, then it's all about understanding and applying the principles and try to create something new and stuff like that. So memorization level yang paling bawah, you memorize ni, ingat, and you spill on the exam, and during the exam, and you got high marks. Well, you survive the exam, but then when you go to the real life internship work, you will know what it means. So I believe students' holistic development is the ultimate goal. I always advise my students to try to put your destination in mind, your target in mind. If you talk about internship, if you talk about career later on, normally companies are looking for CGPA of more than 3.0, but that's not everything. That's not everything. You need to have some other stuff as well with you. Your personal qualities, your soft skills, presentation, communication, negotiation skills, teamwork, analytical skills, whatnot. And I don't have time to spell everything here. But CGPA is not everything, but I'm not discouraging you to score, of course. Don't get me wrong. Most of the companies, they want at least 3.0 of your education qualification, but that is not the only determinant. Okay, you need to bring the whole package to the table to be hired as a new hire. Okay, and few years down the road, your CGPA bila you dapat kerja, this is more towards your future, so that you have the right mindset to begin my class. Bila you dah dapat kerja, dapat intern, dapat kerja, so your CGPA will be left at the door of the company. You don't bring it forever. So your CGPA is now at the door, and what it brings with you next, in the next 5-10 years, is yourself. The way you conduct yourself, the way you work with others, the way you convince people, the way you communicate with people, the way you deliver, and your other personal skills. Okay, CGPA ni macam you punya tiket je. Tapi kalau you tak ada tiket, you tak boleh naik lah bus, tak boleh masuk what I call GSC or whatever. You need to have the ticket, the minimum level. But in order to survive, in order to excel in your life, you need beyond the CGPA. You need beyond the ticket. Okay. Tapi kalau tak ada tiket, tak boleh masuk. So that's the thing that you have to understand. So I hope it's a two-way street in my class. Kalau tak faham, tanya. Kalau ada point nak discuss, well, go ahead, let me know. Either you want to interject during class or you want to ask questions at the end. I'm open. You can ask questions in WhatsApp as well. Okay. So I don't like one-way street. Saya je cakap and you absorb and done. That's it. That's not how it's going to work in the future. Okay. It's a two-way street kind of thing. So yeah, done. That's all for today. That's about 56 minutes more or less. So do you have any questions about the course intro, at least for now?
Doktor.
Yeah.
Saya cuma nak confirmation.
Okay.
Monday 1 to 2 PM dengan Rabu saja kan? 1 to 2 PM juga kan?
Yes, Monday 1 to 2, Wednesday 1 to 2. Yang lain semua sama. Macam dalam jadual asal.
Alright.
Okay. Alright. Okay, any other questions? Yeah, okay. Faris, tolong capture Shreyas lah. Shreyas, ke betul? Do I say your name correctly? Yeah, we have a website group just created by Faris. You might want to contact Faris. Kalau boleh tolong capture Shreyas ke add dalam group. Who else is not in the group? Okay, please. Good. Boleh join the link tu. Sorry, Haziq, are you talking? Tak. Okay, right. Okay then. Any other questions? So join the group. I will include many things in the group as well. So most of the stuff I will include in on eLearn. Cumanya kadang-kadang over time, you know, new link or something that you can watch right away. I can forward into the group. Any other questions? So all good so far? Nope. No question. All right then. Okay. So kalau tak ada apa-apa, then okay, attendance is okay. Don't worry about attendance because I'll just grab your online attendance through WebEx log. Okay. So I can just extract your login time through WebEx log. So it will say the duration. So but then well, you understand online classes, right? Online class ni I don't see you because we want to save your data and stuff. So I hope you remain engaged, okay? Because this class is not for you. This class is not for me, it's for you, right? So kalau dalam kelas, at least you are in front of me and I can see your attention. I can see your, kalau you tak faham, you kerut dahi ke, I can see right away you tak faham. But online, I don't know. If you tell me you don't understand, then I will address accordingly. If you don't tell me, then my best is just to assume that you know everything. Okay? So that's why if you don't understand, just ask. Don't be shy. Because I couldn't tell. Okay. Like even kalau you duduk dalam kelas pun you tak faham semua benda kan. So online ni, you know, you understand the limitations going through the previous phase of pandemic. So you know your learning rate and stuff. So it's gonna be a bit more challenging compared to physical classes. But well, let's try our best together. If you don't understand, tell me, then I'll try to address to my best. Okay. So I hope you remain engaged. Well, you can turn off and go somewhere else. But get back to my point, this course is not for me, it's for you. Okay. If you think you want to learn as much as possible, then stay engaged, listen, and try to understand and discuss. Right then, so I'll see you tomorrow. Okay, tomorrow morning. Okay, no questions, right? Done, 4 p.m. Bye-bye, take care, stay safe. I'll see you tomorrow, inshallah. Assalamualaikum.